Right. So let me make it a little bigger. All right. So week 8. So object-oriented actually system models, in order to actually understand how we going to model the object-oriented analysis models, we need to have a kind of an idea how the object-oriented programs actually flows. So you may have learned object-oriented programs like Java or maybe C++. So usually in object-oriented programs, we are considering usually three layers or three architectures, I would say. So we have the presentation tier. So basically, the presentation tier present the data to the users. But when you design the presentation tier, the object in the presentation tier, we are we are not actually, we are just ignoring how the transformation being made to reply to the request of the user. So this is one kind of objects we can call it as an now for example, in this case, the student is trying to access something from the database, so he is input some information through as a window object. So eventually that goes to an object called a student object on the system. So the object of the window are basically the presentation tier. The object in the presentation tier communicate with another object called student object. So this is the call. This is, we can actually call it as a kind of a logic or domain tier. It's try to handle how the object, how we are going to present the logic into the object, right? So it actually ignores how the data is stored and what ways it need to be presented to the student, but it just give you some kind of an idea how the logic, how the flow of information work in this kind of environment. And then we have the database object or the data management tier, third tier. So that actually focusing on how the data is being stored, but it ignores how to deal with these data. So each of these tiers are focusing on their respective areas, ignoring the other area. So how it works is just to by combining or the communicating each objects we created in each tier. So basically, this is how the object-oriented programs, the program flows, how it had been designed. So this aspect has to be sometimes reflected in system analysis models when you use object-oriented approach. Now, in the object-oriented programming, usually we describe the object-oriented programming codes or programs. We tend to use two important aspects. One is called the objects. One is called the classes, right? Now, classes actually give a kind of, I would say, like a kind of a template or the structure, how the object's going to work, or objects going to associate with each other, right? And then the object itself contains the logic as well as the information or the data about the, for example, in this case, we can say we have a class called vehicles or the cars, and then we have the objects of each of these in each class, in this class. For example, you can have Mercedes vehicles, BMWs, Audi, etc., etc. So each object has its own properties, right? Properties like, now you know the properties that we have studied in databases, right? So properties in this case is quite a little different, but we can take it same as databases in at initial stage, like attributes, right? And also it has the important thing about the object is it has the methods or the logic that we're going to build in each of the object, right? So object is how it does it. Now we have the vehicle or the car type of objects. It will communicate with other type of object by passing through some messages, right? And the data itself, actually data stored itself by each of these objects based on the template provided by the class. So this is how actually object-oriented programming works in the real life. So when it comes to the object-oriented requirement models, the object-oriented requirement models actually built on this scenario or this sort of logic. We use object-oriented modeling notations or different kind of diagrammatic notations defined by object-oriented, what do you call object-oriented management. They are the one who actually introduced these notations or standards as a standard modeling technique. So we are using their standard or UML technique. So the object management group is a group of scholars, actually a bunch of kind of professionals. They are the one who promote the theory and practice of object-oriented technology for requirements modeling, basically. So they give the kind of a common architectural framework for object-oriented analysis and design. So it will give a kind of a formality or standard between the industries when you use these notations to design the classes and the diagram for object-oriented programs. So like what we did in structured analysis as object-oriented system requirements also use different types of diagrams or different types of models to represent different aspects of the object-oriented programs. Now, one of the key things, like what we actually in structured analysis, you may have noticed that we actually start the modeling process by identifying the use cases, events, right? And then we try to identify the what do you call the entities, or we create the entity relationship diagram, and then of course we create all these data flow diagrams, etc., right? So that is how we processed, but we have ignored the entity relationship diagrams because we have already done that. The same approach comes into the object-oriented modeling as well, because first we need to define the use cases, probably using the event table, and then we need to define what do you call these classes. So in object-oriented analysis, we usually term classes as domain classes, because these classes eventually convert into the programming classes or design classes in subsequent core processes, right? Because we are focusing on system analysis core processing. Remember, in the system development life cycle, so we are the domain classes actually plays a vital role in designing object-oriented analysis models. So that is kind of a starting position, I would say. But again, we need to know how all the concepts that we have learned in earlier few weeks with respect to the events are very useful here as well, because the events are the events and the object classes or domain classes probably form the object-oriented models in object-oriented domain. Right. So there are various types of object-oriented requirement models can be built in if you use this methodology to define systems. So one type of model is called use case diagrams. Now, when you build the use case diagrams, we try to identify different actors. Now here, remember that I am using the term actor. I'm not using the term external agent. It's quite different, right? Technically, it's quite different, external agent and the actor. Remember, external agent, we use that term in data flow diagram, but here I'm not using that term. We are using the term actor. Now, when you use the object-oriented models, we need to clearly distinguish the computerized or the application part of the system plus the people or any actor associated with that application. Now, in your subsystem, probably when you define your data flow diagrams, the doctors in your use case, the case study, the doctors or the nurses probably you treated as a process in data flow diagram. But in this case, in object-oriented requirements, doctors, nurses, if you consider external agent, sorry, internal agent in your diagrams in DFD. Now here we treat it as an actor, or the customer is actor, doctor is actor, nurse is actor, um, and whoever interact with your application, computerized application, is treated as an actor, right? So that is what you need to remember in here. So the use case diagram basically identify all these actors who are interacting with your application and the use cases, right? So use cases basically define the goals. What are the goals that actor is trying to achieve using your application, right? So we can, when it comes to the use case diagrams, we can also actually show in a different component or the aspects of your subsystem using different use case diagrams, right? We'll come to that later on. And then we can have a kind of a textual model called a use case description. So each use cases, now remember we have identified the use cases, right, in the event table. So these use cases, now probably when it comes to these use cases, when you identify use cases in your structured analysis, the event table probably you may need to slightly modify it to suit into the object-oriented analysis. Now remember, right? Sometimes you may not take the whole diagram or whole event table as is in object-oriented. Maybe you need to slightly modify it to suit into this requirement. Okay, so remember that. So the use case description, basically what we do is we take all the use cases you have identified in your event table, and then we describe in detail what are the steps actually involved in each of these use cases, how we process the information, right? Who are the other stakeholders? What are the any preconditions that involved in the use case? What are the post conditions, right? Are there any other logic involved, or are there any exception conditions involved, etc.? So there are lots of information can be integrated into the use case description, because use case description actually is the stepping stone or the main building block for the programmers, that they can use this to program or coding the system by identifying the necessary objects, right? So that is actually plays a vital role in object-oriented analysis. And then we are using again the activity diagram. Remember the activity diagram we use to identify the business processes in your subsystem. So again, we can actually stick with this activity diagram to describe the use cases, because the use cases textual description sometimes if not clearly visible for the programmers and our team members in our project, not clearly visible how the system actually flows, the information flows between different parts of the system. So we can use the activity diagram to describe a little bit more in detail the use cases, right? So that is the purpose. So we actually use activity diagram for the aid, part of the aid for a use case description. And then we have a system sequence diagram. Now, system sequence diagram basically we use to defines the input and the output, right? Now, remember, the actors are interacting with the system right now. They are exchanging information. For example, if I am an actor, now here I am actually interacting with the application, this application to deliver the lecture to you, right? Deliver the lecture to you. So what are the actions I am taking, and then the system is response to my actions, right? So how are we going to show that action and the responses, action and the responses? We can use these so-called SSDs, or system sequence diagrams, to show that interaction, right? And then we have the state machine diagrams. Now, state machine diagram is something that interested in for certain reasons, because when it comes to the objects, each object going through different steps when it transferring the information from beginning to end, right? So sometimes we need to actually capture the state of the object. What is the state of the object in a given point of time? Because sometimes state information is very important. State information very important in terms of to implement the business rule. For example, if you think about the sales, right? Sales is an object. If you treat the sales as an object in our system, we don't want sales to be dispatched to the customer unless he or she has paid fully for that particular order, isn't it? Sales order. So that sales order, or the sales, we need to capture the status of the sales order object, because we don't want to allow the sales of the object from transferring from the order to shipped state unless the customer has paid it fully, right? So therefore, there are certain objects we need this status information in order to make decisions, so in order to make sure that it will not transferring from one state to another state before something happens. So the state machine diagram basically shows these status conditions in your subsystem, right? So so you can see there are kind of different aspects in your system can be shown in different models. So you may have realized up to now it's quite different, right? The models that we are talking here is quite substantially different to data flow diagrams that we have described in previous 2 weeks, right? So data flow diagram basically focus on only the processing aspect of the whole system, right? We are not going to distinguish how the computerized part or the application part of your system with the actors who are involved in that, right? Here we are distinguished that. So that is obviously two different parts in these two models, right? So now I'm just the hierarchy of the our next 2 weeks. So what we are going to cover up. Already finished the left-hand side of the diagram. You can see the traditional structured models. So now we are in the right-hand side of the in our models. Right now, remember, even though we are in the right-hand side, the events, use cases, user stories, and the event tables are really important, because you may slightly, or maybe you need to not slightly, or maybe you need to remodify or restructure your events to suit into the object or may not. Right? It depends on how you have modeled your subsystem, right? Now, as I mentioned before, so these are the models. So these are the models we are going to build. So the requirement, in the system development life cycle. So after system analysis stage, we are moving to system design stage. So whatever the models we build at the system analysis stage, the object-oriented models, we use these as an input to the design stage to further enhance and build our design object-oriented models, right? Sometimes we need to combine different diagrams or the models to form the design models in the design stage. So you can see when it comes to the design stage, we may have actually fewer models because some models we are trying to combine to form a new design models. But we are not going to actually touch the design models or design object-oriented models at this stage, because this is something we can that you will cover in future advanced models, right? So we are not going to cover it. So what we are going to cover in here is to identify the requirements object-oriented models in this class. So these are the models we are going to focus in coming weeks, this week and the next week. Okay. Right. So first thing first. Now, as I mentioned before, as I indicated in here in this hierarchy. Now here you can see. When it comes to structured analysis, once we identify the events, we actually move into the models, we need to build the entity relationship diagrams to define the entities in your the system, right? And then we build these models. So likewise in here, before we move into any object-oriented models, we need to build the class diagram. Actually, in system analysis stage, entity relationship diagram and the class diagram basically looks same. So it actually reveals the same information, but there are some quite little bit of differences between these models. Okay. So when you build object-oriented models, you can actually represent two types of description or two types of information in your object-oriented models, right? The first thing is we need to first build the components of the system, right? We can represent the structure of the information system we are building, right? And then once we have the structure, we can put the logic to the each of these components that we have identified, or each of the structural objects that we have identified, right? So some of the object-oriented models focusing on structural information, and some of the object-oriented models focusing on the behavioral or the logic part of the system we are trying to build. So the class diagram basically is a structural object-oriented model because it provides some definition regarding the components or the structure of your subsystem. So that is actually very important, right? Very, very important when it comes to the object-oriented analysis, to identify the structure of your system by using a class diagram. So other models like use cases, system sequence diagrams, etc., etc. It focuses on the activities or the logic performed by each of these components. So so whatever the models we are building in object oriented, you need to remember that each of these models have a very clear relationship with each other. And then obviously we are representing the computer program that we eventually be created in the system. So that is we are focusing more on a technology part and in object-oriented system models. Okay. Right, now first thing we need to identify what do you mean by this class diagram. Sometimes we actually call it as domain model class diagram, right? Domain model class diagram in the system analysis stage, right? So what do you mean by a class, right? Let's actually clarify these small issues. So what do you mean by a class? A class is a category of classification, right? We use to describe the collection of objects. For example, it can be a student. Student is a class, right? Because if you think about the class student, you can have different objects. Like we can have Darcy, Dan, Ang, Joseph, June, Kai, right? Moon, Heng, Nicholas, Diction, right? So we have different objects in the student class, right? If you think about class like car, we can have Mercedes, BMW, Toyota, Nissan, etc., etc., different objects, right? So that is what we mean by the class, right? It's a category of classification that we use to describe a collection of similar objects, right? That is what we mean by the class. So domain model class means classes that describe the object in the problem domain. If you think about one particular problem domain or the problem that we or the opportunity we are tackling in, so the any classes belongs to that particular problem domain, we call it as a domain class, right? Domain class. So the class diagram is a UML diagram type that we shows what are the classes and what are the attribute associated in that particular class, right? Classes and the attribute. It's like an entity actually. Any entity in an entity relationship diagram, right? In an entity relationship diagram, we identify the entities and we identify the attributes, right? Or characteristics of that attribute. So same applies when it comes to the class diagram. We identify the class and we identify the attributes of the class. But remember, in the class we have different objects, right? Different objects. But at the design stage, in addition to these attributes, we put some methods or programming logic associated in each class. But at the analysis stage, because we are in the analysis stage, we are not going to actually put any software methods or the methods associated in any class, right? So we are totally ignoring that part in analysis stage. So the domain model class diagram is a particular type of diagram that we use the classes and the attributes to define the classes involved in a particular problem domain, okay? Because we are not focusing on the software classes at this stage, because eventually these problem domain classes will become the software classes in the later stage and the design stage. So this is an example of a class, a small class, right? For example, you can say a student class, right? How are you going to show that in a class diagram? We just this is a UML kind of box, so we just open the box and there are two components. First is the name, and the second component is basically the attributes associated in a student, and then this student class can have different objects, right? So remember that. And now in the design stage, we are adding one more information into here, and actually a couple of information here. We are defining what are the type of data associated in each attribute, and also the classes associated in this, the methods associated in this class. For example, the student class has associated in many methods. In other words, what are the functions? What functions associated in this class? So that is an example of a design class. So we are not actually considering the design class at analysis stage. So this is the analysis stage class we are focusing on. So eventually this design class is where we convert into the programming code. Now this is an example of Java program code, which eventually we convert this to kind of piece of code. This is how we're going to define the student class in a programming language. So you can see that we have defined attributes, and we define the constructors. So what are the or in other words, we define the structure of this class. That is what we mean by the constructor. And then we define the methods. Methods are this here. We have identified, so we define that methods, and then we write what are the functions, what are associated in each function, etc., etc. So basically, what we are doing is we are creating a template, right? So we are creating a template how the class is going to behave. So what are the functions associated in this class, and what are the data aspects associated in this class. So we define everything in this particular class. So basically, we can say when we design the class in that analysis, try to define the structure we are trying to build in, right? So that's something that you need to remember. Right, so let's focus on our domain classes. We are not actually focusing on here this type because this is not what we are interested in this unit. We are defining the requirement models, right? So the domain classes. Now, as I mentioned, the domain classes has no methods, right? No methods. So remember, we use the capitalized class name always. So first letter is capital. Sometimes you can actually, I'm not totally worried about that, but these are the industry kind of standards usually we use. And then we represent all the attributes. So attributes names are not capitalized. We can use the camelback notation. So now this is a camelback. You can see the second word starting with the letter, capital letter always, right? Second phrase, basically, or second word. So this is an example of a simple domain class diagram. It looks like a kind of an ER diagram, isn't it? Actually, it looks like the ER diagram at this stage. So you can see here there are three classes. One, we have the customer class, we have order class, and we have a order class, order item class. Now remember, we have built the same kind of a ER diagram in our database class in last semester, right? One order can have many order line items, right? So same principle applies here. We can actually show that information in object-oriented models as well. For example, here we have a cardinality relationship. So customers places an order, right? So we can say one customer. So we put one here, places zero or many orders, right? So here now remember in cross foot symbol we use many n in this side, right? So here we are using zero plus dot dot and the asterisk stand for many. And it says zero or many, one customer can place zero or many orders, right? And then it goes to other way around as well. If you have if you have an order must belongs to one customer, right? One customer. So same applies in this relationship. One order may contain at least one or many order line items, right? That is why we have one here. Dot dot asterisk means many, one or many, right? So one order contains one or many order line items, and if you have one order line item, it must belongs to one order, right? You can't have order line item without having an order, right? It must belongs to one order. So that's why we put one here. So likewise, we can actually show some important things, right? We haven't actually shown these kind of associations or relationships in our ERD diagram, but in class diagram we can show that more information. But there are some more information we can show in the class diagram. I will let you know later on. So this is one type of information that we can show in the class diagram. So we in class diagrams we called it as multiplicity. These called multiplicity, but in the relationship diagrams we call them as what you call cardinalities, right? We call here as multiplicity, right? So the multiplicities can have different kind of relationships: zero or one, zero or many, or just one, or zero or many, or one or many, etc., etc. So you may have seen that this is an example of ERD diagram, right? So in ERD diagram, if you have this small model at the analysis stage, when you convert to the class kind of diagram, it looks like this. So here it says one team member may have many players. So one team member may have zero or many players. So you can see actually it's quite similar to the earlier ER model, right? Because analysis stage there is no much different between the class diagram and and ER diagram. But there are some additional information can be shown in class diagram at the analysis stage. So let's move to that now. Now, if you think about this diagram, so this is now you need to think about like this, right? Now here we have a customers accounts and the branches. So customers can have one or many accounts, and each account must belongs to one customer, and one account may belongs to each account may belongs to one branch. You can't have accounts belongs to multiple branches, right? That is why we put one there, and each branch may have zero or many accounts. We can have branches without having accounts as well, so I just put zero or many. And then each account may have one or many transactions, because each account must have at least one transaction. Even you open an account, that means it's a transaction as well, right? So that means it must have one or many transaction. So each transaction must belongs to one account. So that is how we read multiplicity. Now this is something very similar to ER diagram, because we have expressed these information in our ER diagram if you build the same diagram for the structured analysis, right? So same applies to any, for example, in this case, so we have a courses with multiple course sections, and each course section can have students, and then the students can be enrolled in each course section. Right now, this is a weak entity. Now remember, in ER diagram we show the weak entity as a double line box, but here the weak entity, we call it as an actually association class in class diagram. We don't call it as weak entities. When it comes to the class diagram, we call the association class, right? So if you, whenever you have many-to-many relationship, we usually have the weak entities, right? Remember in ERD, the same rule applies in the class diagram. Whenever we have many-to-many, we have an association class. So how to show the association class? This is the way, right? So the weak entity, we show it in a kind of a dash arrow into this class. So we record, in this case, we record the student grades. So students are enrolled in specific course sections, and then their grades are recorded in the course enrollment entity or the association class. Right. So there are so many other information that we can show in class diagrams. So this is one type, the association kind of thing, and the second type is actually generalization and the specialization kind of relationship, right? Now in a class diagram we can place most of the classes in a hierarchical relationship, right? So we can have more top classes, and then we have subordinate classes of each top class. So we can say super class and the sum. For example, if you think about vehicles, right? So vehicle, if you think about vehicle, we can have different types of vehicles. So the vehicle itself is a super class, right? It's a general class. And then when it comes to the vehicle, we can have car, we can have vans, we can have lorries, we can have buses. All are vehicles, right? But there are different types of vehicles, right? So these different types are called subclasses, right? And even if you go go further down, right? If you think about car, a car may have different types of cars, right? We can have sedan cars, can have SUVs, hatchbacks, etc., right? So you can actually place classes, or we can break the classes into more super class, more generalized classes, and more subclasses. But the thing that you need to understand is, if you have a more generalized class and more subclasses, inheritance. So each of the attributes in a more general class inherits its attributes to its subclasses. It looks like this. Like we have parents, right? Our parents inherit some of our behaviors, isn't it? right? Same applies to class diagram. If you have a superclass, these attributes in the superclass inherits to subclasses, right? Subclasses or the children's. That's what it says, right? So how can we show that in a class diagram? This is how we show more general. So we can say, okay, so motor vehicle. Now we use this symbol, this diamond kind of symbol to show, right? So the motor vehicle is a more generalized class, and we have specialized subclasses under the motor vehicles: truck, car, tractor, right? Now, all these are motor vehicles because there are certain characteristics shared by each of these. For example, motor vehicles can have motor, we can have a gearbox, right? We have a engine, right? We have a suspension system, etc., etc. So all these are shared by each of these type of motor vehicle, right? And then if you think about car, we can have more specialized cars like sports cars, sedan cars, SUVs, etc., etc. So again, each of these are actually inherits the some characteristics of the car, and also it inherits most of the characteristics of the motor vehicles as well, right? So this is something that we can actually show in a class diagram, which actually we are not able to show these sort of relationships in entity relationship diagrams, right? So that is one of the obvious difference between ERDs and the class diagram. Now here, that is another example. Here I have put more generalized classes and more specialized class. Even the motor vehicles, we can actually call it as a subclass of the transport, right? So we can have trains, we can have ships, we can have trams, etc., etc., as a method of transportation, right? Motor vehicle is a one subclass, right? And even the sedan cars can divide or categorize into electric vehicles and more the gasoline type of vehicles, etc., etc. So likewise, we can actually more generalize. We can put more generalized, more specialized. We can add these categories of classes when you build this model to represent our objects in or the classes in our subsystem. So usually, now for example, now this is an example of when you apply this concept to the specific scenario. Now I have used our case organization, Ridgeline Mountain Outfitters, the sales object, right, or sales class. Now here the sales class, you can see we have three types of sales, right, or three sub classes. We can have online sales, we can have in-store sales, or we can have telephone sales, right? Now, the sales class has a certain attributes, and each of these subclasses have its own attributes as well. Now, remember, the sales class attributes inherits its attributes to each of these subclasses, right? Now, actually, when you think about the sales, there is a no transaction called the sales, right? Actually, we may have one of these transactions. We can have either online sale, we can have in-store sale, we can have telephone sale, right? We don't call a sale. We call one of these, right? Because whatever the transaction happens with respect to a sale, it has to be one of these, not just general sale, right? So sales, we give a special name, we call it as abstract class, right? A class that allows subclasses to inherit characteristic but never get instantiated, right? Instantiated. So you never have any instance in our database with instance called a sales. We have instance called online sale. We have instance called in-store sale. We have instance called telephone sale, but not a sales itself. That is what we mean by the abstract class. It's an abstract class. But we have more concrete classes, right? So these are called the concrete classes because each of these classes can have its own instances, right? That is what we mean by this. So abstract class, no instances. A concrete class is where we have the instances or the records, right? And then remember, but abstract class inherits, or sorry, concrete class inherits the attributes of the abstract class. For example, if I ask a question, how many attributes the online sale have? You need to tell 2 here, and a bunch of attributes coming from its a more superior abstract class, right? So sales, date, time, priority code, SNH, tax, total amount, mountain bucks, right? All these attributes are inherited to each of these. So these plus time on site plus chat use are the total attributes in the online sales. So likewise, each of the other concrete classes in-store sale and the telephone sales also inherits the more abstract class attributes to here. So we show that in a kind of this diamond, right? Diamond pointed towards more abstract class. So this is another example. This is a very typical bank example with different accounts. So you can see now early example I have shown you the early example here. Where is that? Here this example I have modified here to include the inheritance relationship, right? So here we have the customers open accounts, right? Actually, customers open one of these accounts, right? Either savings accounts or checking accounts, right? In different branches, right? That is what we mean by this, right? So we can say we don't have a instance in any account, right? So this is a more abstract class. But actually we have more two concrete classes like savings account and checking accounts. So customers open either savings account or checking accounts, or open both of these accounts in different branches. That is what we mean by that. So whatever the attribute it inherits to its concrete class, plus it also inherits this relationship as well. Okay, this relationship as well. So this is one of the key features of a class diagram. We can actually show these more minor, very kind of different kind of relationship between different classes, which is not actually obviously can be shown in entity relationship diagram, right? And the third type of relationship we can show in class diagram is called the whole part relationship, right? So this is a relationship between classes where one class is part or a component portion of another class, right? It can be a part or the component portion of another class, right? So therefore, the whole part means we can show two things in the whole part relationship. It can be either aggregation or it can be a composition, right? Now aggregation means sometimes we can have a kind of relationship where if you take out the sub classes, each subclass can actually recognize individually when it removed from the main class, right? Classic example is we can have classes and the students. So students are enrolled in the classes, right? Or different tutorials. If I take out the students or the classes, or if I delete the classes, still the students exist in the system, right? It has to be existing the student, right? We can't get rid of students as well. So that is what we mean by the aggregation, right? Aggregation means that. So classes student belongs to the class, but still when you delete the class, a student still exists. But the composition is the other way around. It implies the relationship where the child cannot exist independently of the parent, right? Or parent class. For example, if you have house with say 5 or 6 rooms, if you demolish the house or if you delete the house, there is no rooms exist in the house, or no children exist in that parent, right? So so obviously you can't show. For example, another example, if you remove my arms and my legs and everything, I'm not a human at all. So likewise, so you can actually show different parts. So aggregation we show in this diamond symbol without filling it. Composition we show it in another diamond symbol but with the filling, right? So this is the difference between these two. So how can we show it in a diagram? This is how we show it. Now this is an aggregation example. So if you think about computer class, in the computer system or computer, we have processors, main memory, keyboard, disk storage, monitor, etc. So everything need to be aggregate to consider as a computer, but still each of these components, it can exist independently to each other, right? If you get rid of each parts, we can identify clearly this is processor, this is main memory, this is keyboard, etc., etc. Yeah, so in the class diagram, actually there are three types of relationships, right? Three types of relationship. It can be either association relationship, right? Or that means a weak entity between two entities or two classes. And it can be either whole part relationship, or it can be either generalization specialization relationship. So these are the three relationships can exist in any class diagram, right? Yeah, so that is something you need to remember in the class diagram. So if you come back to our case organization, Ridgeline Mountain Outfitters, remember they are embarking on two projects, consolidated sales and marketing project, and there's another project called what do you call that, trade show system project. So they have identified for CSM, so consolidated sales and marketing project, they identified 27 domain classes overall. And then they have created now consolidated sales and marketing is a kind of a collection of many subsystems. So they can create actually domain model class diagram by going through all 27 models, or they can actually build separate domain model class diagram for different subsystems, right? So so this is an example of sales subsystem of their consolidated sales and marketing project. So this is the class diagram or domain model class diagram that they have built in CSMS sales subsystem. So you can see that they have used the whole part, sorry, what aggregation, sorry, specialization, what do you call this, specialization, yeah, specialization, generalization, specialization, relationship in some of their models. So basically they don't have whole part relationships in their sales subsystem domain model class diagram, but they have specialization, generalization relationship exist in some of these classes, and also association relationship existing here as well. Right, so this is another example. Now this is a customer account subsystem. So this is sales subsystem, this is customer account subsystem. So they have identified the relationships. So they use the UML notations to identify the relationship. Now here we don't have any generalization, specialization, or whole part relationship in this subsystem, right? And then what they have done is they use these two subsystems or the class diagrams of these two subsystems, and then they created the grand big what do you call, the bird's eye view of their total CSMS subsystem by integrating all these two models. Okay. And then based on that, we can actually build other models for the CSMS project as well, right? So we may have order fulfillment subsystem, marketing subsystem, reporting subsystem, etc., as a part of CSMS project. So we may have built, but if you have purchased the book, you may refer to chapter 3 of the suggested reading book, and then maybe you can actually create that bit, but we are not going to touch on that. Okay, right? So that is about the class diagrams, right? That is about the class diagrams. So now we can actually move to so once we have clarified that, we can move into other object-oriented models. So I'm going to now give you an introduction to the use case diagram. So I'm not going to touch the other stuff. We'll go through the other 4 models probably in coming next week and then in the coming weeks. Okay. Right, now let's recap what we have learned so far with respect to the use cases. Now use case analysis is very important. You guys have already constructed the event table, right? Identify the use cases. Now what do you mean by the actual use case? Because we need to do this analysis. We call it as use case analysis because we need to identify all the business processes, right? So use cases basically give you kind of an idea what processes your subsystem need to focus on, right? That is why we trying to analyze the use cases, identify the use cases, right? So what do you mean by the use case? Now the use case is from the object-oriented point of view. Actually, we can say it's an activity that the system perform or the application that you are trying to build perform, right, or carried out. Usually to a response to a user request, right? So there is a trigger coming from the user, right? Now remember, I'm using the term user or the actor, right? So trigger coming from the actor. So the use case is a process. We need to the application process, application component. It need to respond to that particular trigger appropriately. So what are the things it going inside the use case is what do you mean by the use case analysis, right? So there are several activities going on inside the use case. So that is what we mean by the use case. So then the next one is the actor, right? So actor, remember in the object-oriented analysis, actor is the role that played by a particular user, right? It can be, in your terms, it can be a doctor, it can be a nurse, it can be administration, or it can be a customer or the patient, or it can be a supplier who supplies any components, right? Or it can be a pathologist, or right? So likewise, there are various actors in your system. It depends on which system you are focusing on, right? And then basically the actors resides outside the system automation boundary, outside the application boundary, in other words, right? Now remember, in very first week I have mentioned automation boundary, system boundary, 2 different things, right? System boundary and the automation boundary is 2 different, because in the data flow diagram we are talking about the system boundary, but when it comes to object oriented we are talking about the automation boundary, right? Okay, so 2 different things. Right, so we know how to identify the use cases. I already have told you how to do that. So there are basically 2 ways we can use to identify the use cases. We can use a goal technique, right? or the event decomposition technique, right? So if you focus on the user goal technique, basically we focus the elementary or the goals of the user, and then we define the use cases based in the elementary business process level, right? I think I gave a clear description of what we mean by each of these. And then we use the CRUD analysis to make sure that our subsystem or whatever the system we are developing is have enough coverage of all the use cases to deal with the objects or the entities or the classes we have identified. So same principles, although all these principles what we have learned now applies here as well. Okay, that is something that you need to understand. So what do you mean by the use case diagram? So use case diagram is a kind of a graphical way of depicting or graphical way of showing all the interaction among the different parts of the element that we are trying to build in, right? We use so I'm use the term the system, right? So the system actually here is something that you are trying to build in. Your subsystem is the system, right? Or the application is the system you are trying to build in, right? So we use the diagrams, or we use UML notations or standard notation to define these objects and the system in your application, right? That is what we mean by the use case diagram. So what are the symbols we are going to use? What symbols we have to use, right? So this is now these are the typical symbols we are using. So we are using the actor. Actor we show it in a stick figure, right? Now if you diagrams.net application, now remember that is the application we use to draw the diagrams. You may have find this stick figure. Probably I may show you later, maybe during the tutorial or the lab time. I'll show it. So there is a stick figure. So that is the actor. That is the role or the actor's role. Now remember again, you need to remember this is the role, right? Not the name of the person. Okay. There is a role performed by a particular person. It can be role performed by a particular system as well. Maybe there is another system interacting within your application, right? So we use this stick figure to show that. Okay, and then this black block box is called the automation bound. That is the scope of your application. In other words, right? Automation bound application. And then there is a connection. Now then you have this Eclipse. This is called that is your use case, right? And then we are connecting the use case with an actor using a line. So what does it mean is it shows you how the actors participate in a specific use case. So who are the actors are authorized to participate in a specific use case, right? So that is what we mean by this this line. Right, so let's go a little bit more in detail about the use case. So what is the use case? This is just something I wanted to give you a little bit more details. A use case, we can say actually a use case is a behavior pattern or pattern of behavior of the system that actually exhibits, right? Or in other words, how the system is responding. What is the behavior we are building into the system? How it's going to respond to a particular request by the user, right? So the use cases that we are trying to build, or the behavior trying to build, or the use cases that we are trying to build is a kind of it has a sequence of actions which takes the system to get a particular target, right? It actually producing something, okay? It can be producing something back to the user, or it can be producing something to some other subsystem, or it might be a response that it produces to save something in your classes, right? Etc. etc. But at the end of the day, the use case is the actions taken by the component of the system. So that is what we mean by the use case. And then use case also a dialogue between the actor and the system, right? So that is why we show in the line earlier here, the line shows the dialogue, right? So that is a relation. So this actor participate in this use case means there is a dialogue going on between the user and that particular use case. So that's what we mean by that. So how are you going to write in the use case diagram? So how can you use the use case diagram to represent your subsystem? So you know the use case is to describe the sequence of actions, kind of it provides some measurable value to the customers who participate in it. Now follow these steps. So use case names usually need to be begin with a strong verb always, so remember verb and noun, right? First verb and then the noun. So strong verb need to be there in the use case. So I think I have emphasized that in your feedback in my tutorial, students. So you may have get my when you define the use case. That is very important. So when you name the use cases, please try to use something in the domain or the domain terminology, because you are now working in the medical industry. So you need to use some terms using that. Maybe you can Google it if you don't know the term. Something that you need to familiar with. So normally when you draw the use case diagram, we place all the primary use cases in the top left corner of the diagram. Now here we actually missing the box, what we call the automation box. So we need to actually define the automation box. So for example, if I take this diagram, make sure you need to define the automation boundary like this, okay? So this is the automation boundary. So usually we tend to place all the primary use cases in the top left hand side in the diagram. That's what we mean by the third point telling you. And then so this implies the timing consideration by the stacking the use cases. So when you're stacking, you need to imply the timing consideration. The use cases, the primary use cases, which usually occurs first, need to actually place in the first place, right? And then the use cases which occurs last, probably. So for example, in this case, closing the account actually occurs last, right? Open accounts occurs first, right? So we stack in importance according to the importance. Most important to least importance, okay? So that is something that you need to remember, and I think there's some more. And then there are some more you need to actually understand. Now, when it comes to the actor, as I mentioned, as I mentioned before, it can be anything, right? It can be a person or the role played by the person. It can be sometimes external organization like government, or maybe another supplier, right? Or even it can be external system that plays a role. For example, it can be another system like payment process or any other subsystem. In your case, your colleagues are defining other subsystems, so there can be another subsystem in your whole system interacting with your subsystem, right? And then these things you need to be remembered, unfortunately. So place your primary actors. Now, likewise, what we did in the use cases, you need to place your primary actors in the top left corner of the diagram, right? So top left corner. And then that draws the actors to the outside of a use case diagram. Now, remember, don't place the actors inside this, what you call the automation bound, right? It has to be placed outside. So this is the automation part. This is the application you are building in. Now remember to name the actors usually use a singular business relevant nouns like customer or payment processor, customer support, tax authority, etc., etc. Then associate each actor with one or more use cases. Right now, for example, customer can interact with a bunch of use cases, right? So if we interact with many use cases, probably this might be a web portal, right? Through the web portal, the customer is involving or interacting with a bunch of use cases, right? Searching the item, placing orders, obtaining help, etc., etc., right? So that means we need to actually have lines related to each of the use cases that the customer is associated with. And then, as I mentioned before, actors represent the roles, not the positions that they are holding in the organization. So the roles that they perform is what matters. Okay. And then most importantly, we need to use sometimes this symbol, system symbol now with this greater than, lower than, using these symbols to indicate the system actors, right? For example, your other subsystem, maybe another subsystem interacting with your system. You can show it using this thing. Sometimes, actually, in some books actually show there is a kind of the heading or the arrows pointed out. There's no arrows in this case. What does the arrow means? Is the information going? We are sending the information when the customer places an order, sending the information to the payment sub process, right? They are not sending any information to our system, but they are getting information from our subsystem, right? So that is why we place the arrow the other side. But if we exchange information here and there in both directions, we are not going to show that in this diagram, right? For example, customer receives and submit information from each of these use cases, but we are not showing the double arrow headed, right? If there is a single information flow, then we are showing it. For example, here the time. Now remember the temporal event, right? Temporal event, you need to use a time actor, right? Time, right? For example, here submit the taxes use case invoked by the time actor here. So the information comes in. That is the trigger. So trigger comes in to this particular subsystem. So it initiate, it schedule something to submit the taxes. Right, so these are the bits and pieces you need to know about the use case, and then yeah. So here, and then you can actually show the use case diagrams in different ways as well. For example, you can show the use case diagram from your whole subsystem perspective. For example, this is a subsystem called customer account subsystem, right? So here the whole customer subsystem, they have shown for the Ridgeline Mountain Outfitters case study. These are the use cases involved in that subsystem, and these are the actors involved in that particular subsystem. You can see the most of the use cases are activated or interacted by the customer. But there are some certain use cases actually only involved or interacted with by the management, right? For example, processing the account adjustments authorized only by or undertaken only by the management, none other than that, right? But if you think about creating and updating customer accounts, customer can do it, customer service representative can do it, as well as store sales representative can do it as well, right? So this is an example of sales subsystem. Here earlier customer account subsystem, now sales subsystem. So now here we are showing sales subsystem, but exclusively focusing on the custom only, right? Now here this diagram shows what are the use cases associated in the custom, right? Customer perspective of your sales subsystem. So here we are showing that. Now remember, in your subsystem also make sure that you clearly name your subsystem, and if you show the whole the use cases for use case diagram for the whole system, write the term all actors. But if you show your use case diagram for a specific actor, you just say actor uh, double dot and the customer, right? In your case, it can be a doctor, it can be a nurse, or it can be administrator, etc., or it can be a patient, right? So you can show in this way as well. Because sometimes we need to actually produce both, because these are the use case diagrams, basically not a diagram we use to communicate with the programmers or other project professionals. What we do is we use this to communicate with our users, right? They can understand this much better, right? This is a presentation purposes, okay? And then this is another example. This is a sales subsystem again, but here in this case there are two actors, sales representative and the store representative. So they are actually invoking all the use cases involved in the subsystem. And there are some other things that we can actually show in use cases or use case diagrams. One of the things that we can show is called the include relationship, right? So because sometimes some use cases need to take help from other use cases, right? So in that case, how can we show that we are getting a help from in that diagram? If I, for example, now if you think about use case, it's a process, right? It's a process. So when you execute in that process, you may need to actually get another help from another use case in the system, right? Or we can say a common subroutine in the system, right? For example, when you search, when you order a product, right? While ordering the product, you want to actually see the comments posted by the other users, others who bought that same product, right? So while you are filling your order, you want to read some comments, so you need to, then that means you need to actually get the service from other subroutine to get that information displayed into the user, right? So how can we show it? We are showing it in the include relationship. So how can show it in the diagram? This is how we show it in the diagram. So the actor student here, the student is borrowing the books, right? So when you're borrowing the books, the actor wanted to see whether there is any fines involved. So this use case has a facility, has a capacity to call other subroutines like check fines. Right now, remember how we included that. So we put the include this keyword inside this notation, and then so the dash arrow, right, pointing towards the sub use case. So here also, here we are checking the reserve books, right? So we need to see whether the books has been reserved while we are borrowing the books, right? So that subroutine, there are two subroutines associated with borrow books use case, okay? Right, so that is called the include relationship. and then we have the extend relationship, the other way around, because sometimes we need to actually put some additional optional functions to add some value to the initial use case, right? So in that case, we use extend relationship. For example, uh, now here ordering the food, right? The waiter is ordering the food. That is the use case. Order food. But the same time, when you take the ordering food, we need to take service from other subroutine. Like, do we need to order the wine, right? So this order wine use case is giving some additional um, optional functionality for your main use case, right? So you can see here uh, the um, the dash arrow is coming towards the main use case. Include relationship, it goes from the main use case to the other subroutine, but extend relationship, it comes towards the main use case. So we put the word extend, right? So you can see when you design a use case diagram, there can be bunch of extend and include relationships in your subsystem, right? Um, and then also, if there is any condition associated with this subroutine, you can actually place it inside these curly braces. For example, so client P is eating food. We take the services of the drink wine use case if the wine was served, right? Or if the wine was ordered or something like that, right? So we put that condition under which this service is taking inside the curly braces as well. So there are the bits and pieces you need to think about when you place the extend relationships in your subsystem, whether we know under which circumstances we take the service from the subroutine. Okay. Right, so this is an example use case diagram with include relationship. Now here the customer, now this is a sales subsystem. The fill shopping cart relationship. Now here the customer filling the shopping cart. While filling the shopping cart, we need to take the services from search item because customer may need to search the item. So this is include relationship, right? And also the customer wants to view the product comments and ratings, so we take the service from this use case, as well as the customer need to sometimes view the accessories combination in different products, so we take the services from the other. So this main use case actually has three subroutines. One is search item, one is view product comments, and the other one is the view accessory combinations. So likewise, when you define your use case, think about, do I need extend relationship with other subroutines, or do I need include relationship with other subroutines? Okay. So that is another example. This is the order entry subsystem with include relationships, right? Include relationships. Now this is a complete use case diagram. So if you put all these what we have learned now into a final version, it should looks like this. So you can show your boundary, your system boundary, and then a subsystem name, right? And then all the use cases, and then specify whether it's include or exclude. If it is exclude or if it is include, put the condition in which that exclude, or sorry, not sorry, extend, condition with the extend happens, or condition with the include happens. We can put that here. I have actually not included that. And also you can actually show the multiplicity association relationship in your relationship, this line as well, right? So the customer is, now in this case, I have placed that relationship here. A customer can actually place one or many orders, or they can actually check out one or many uh, products as a checkout. So I just place that as well. So yeah, and then same in here as well. So I put the multiplicity relationship in your diagram that you are building. You need to actually show this the whole diagram in your system as well. So include all these extend or include relationship, participation, or multiplicity for your subsystem. Okay, so we will do a kind of an example probably next week. Then you can actually apply that into your subsystem. Right now, remember we are using the case study that we discussed throughout this. What do you call that? Acme Garage case. So we tend to use that in this week, not this week actually, next week, to represent these object-oriented models. Okay. Right, so that's about use case diagram. So that actually concludes the lecture 8, the object-oriented approach to requirement, part 1.